Hi all, welcome to Geeks for Geeks. I'm your DSA mentor, Utkarsh, and I hope you guys are doing well. So let's start with today's problem of the day. So the question is find rectangle with corner as 1. Given an n cross m binary matrix containing only 0 and 1s, determine if there exists a rectangle within the matrix such that all four corners of the rectangle are 1. If such a rectangle exists, return true, otherwise return false. So it is saying that they will give you a n cross m grid in which there can be value 0 or 1. Okay, so you have to tell that whether there exists a rectangle, and the condition for the rectangle is, suppose we are choosing this submatrix as the rectangle, so the value here, here, here and here means in all the four corners it should be 1. So let's see the first example. 1 0 0 1 0 0 0 1 0 1 0 0 0 1 0 1 0 1 0 1. Correct. So for the rectangles it is always means we have to take like this, two bars in the vertical, two vertical bars and two horizontal bars, and the corner should be 1. So if I will choose my one corner as 1, this one, so my next corner is this, because it should be 1 in the bottom left too, and in the top right here we have only 1. So for making a rectangle, here should be equal to 1, here should also be 1, but there is no 1, so we cannot choose these corners as our answer. Okay, so let's see for other corners. Okay, if I will choose my rectangle as this, so here you can see that in all the four corners we have 1. So if we get a condition like this, so we have to return a true, and if we are not able to find like this, so we have to return a false, just like in the second example all are 0, so there are no submatrix where the corners are is equal to 1. So how we can do it? The brute force approach is this, that brute force approach, uh, brute force approach. So what we will do, we will find out all the submatrix and check for its corner. Simple, check for its corners. So how we can do it? First we will run a we have to choose two rows, correct? uh, One this row and one this row, means the top horizontal bar and one for the bottom horizontal bar. So my first loop will run from uh, let me write the pseudocode. Yeah, so my first loop will run for my row 1, which will be start from row 1. Yeah, let's write like this. Yeah, row 1 which will be start from 0, and row 1 should be less than, and row 1 plus plus. Okay, you got your row 1. Now you will find out your row 2. So row 2 will always be after this row 1 below. So your row 2 will start from row 1 plus 1, and row 2 should be less than n, and row 2 plus plus. Similarly, you will find your call 1 and call 2, and just simply check at the corners. Okay, So if suppose this is your row 1 and this is your column 1, so this value you will check, this will be your column 2, this value you will check, and here your row 2 will be there. So this value you will check, this value you will check. Okay, and you will do it like this. So let's write this code. So first find out the size of this matrix. So mat dot size, int m is equal to mat of 0 dot size for its column size. What I told you that we will run a loop for row 1. So for row 1, start from 0. Row 1 should be less than n, row 1 plus plus. Then we have to choose our second row. So row 2 is equal to row 1 plus 1. Row 2 should be less than n and row 2 plus plus. Similarly, we have to do it for the columns. So for int, column 1 will start from 0 and column 1 should be less than m because m was the size of the column. Okay, uh, column 1 plus plus. Now we have to find out the second column. So for int c2, so c2 will start from after this first column. So c1 plus 1, c2 should be less than m and c2 plus plus. Now we have to check that whether all the four corners have 1 or not. So if my first cell, so if mat of row 1 column 1 is equal to 1, and in my row 1 in column 2 it should be also equal to 1, and now uh, I have to check for row 2. So row 2 and column 1 it should be equal to 1, and mat of row 2 and column 2 it should also be equal to 1. So if these four conditions satisfied, so we have to return 1 means true. And if after finding for all these matrices we are not able to get the rectangle, so we'll in the last just return a 0. Let's compile it. Okay, so submit. Yeah, it is giving TLE because if you will see the constraint, it is the value of n or m is less than or equal to 200, and you are running four loops, two loops till n and two loops till m. So the wait, yeah, so the time complexity if I will talk about, so it is n into n into m into m. So it is n into m to the whole square, and your value was still 200. 200 into 200 square, which will be 4. 4 4 is 16, and 1 2 3 4 into square 8. 1 2 3 4 5 6 7 8, which is greater than 10 to the power 8. That's why it is giving TLE. So now we will do some optimization. Okay, so let's take the first example again. So see, for forming any rectangle, wait, let me clean this. 101 101. Here we have 010 010 and 101. So 101. Okay, so I'm saying that you know one thing, that suppose in this row you have to choose two columns, because for making a rectangle your rectangle will look like this now. So in row you have to choose two columns for making one side. Okay, and if you are choosing any two columns, so for making it rectangle in the below rows, that two columns should be also be equal to 1, correct? So what I will do, I will take the help of map. Okay, oh, so I will find out all the pairs of columns which are making the uh, which are 1. So I will find out, suppose here we have 1, here we have 1, and let's suppose here we have 1. So it may be possible that this and this can contribute to rectangle, or this can contribute to rectangle, or this can contribute to rectangle. Okay, anything is possible. So what I will do, I will make all the pairs. So here let also write the indexes 0 1 2 3 4 0 1 2 3. I will traverse this row one by one. So when I will go to this row, so I will find out the pairs which is having 1. Find out the columns pair which is having 1. So only one pair we are getting here, uh, this 0 and index number 3. So we will check in our map whether there was any previous previous pairs with this 0 and 3 index. Okay, so there was nothing. So what I will do, I will just put this 0 and 3. So let's put like this 0 underscore 3. I will convert this in a string and I will put it like this, so it is present in the map now. Now I will move to my next row and I will form the pairs here. So the pairs are only one pair is there, 2 comma 4. So is 2 comma 4 exist in the map? No. So make a pair like this 2 comma 4 and put it in the map. Let's suppose here make this as 1, and also make this as 1. So I can tell you that how we are making the pairs. Yeah, now when I will come to this third row, so how many pairs we can make? This, and this, 3 pairs. So first pair will be index number 1 and index number 3. Is this pair exist? Not exist. Put it 1 comma 3. Sorry, 1 underscore 3. The next pair will be 1 comma 4. Is it exist? No. So 1 underscore 4. The next pair will be 3 underscore 4. Is it exist? No. So also put this 3 underscore 4. Now come to next row. Here you have pairs. This 0 comma 2. See, for 0 comma 2 exist? Not exist. Put this also. Then 0 comma 4 exist? Not exist. Put this also. Next, see this 2 comma 4 exist? Yes, 2 comma 4 exist. So it means 2 comma 4 exist means in the previous row somewhere this 2 and 4 was as 1 in the same row, and here you also got this as 1. So it means a rectangle can be formed. So we will return true. If we will do like this, so our time complexity will be reduced because we are going in each row. So n for each row, and then we are making pairs in this. So since this is the size for this is m, the column size, so the pairs we can make in m square, correct? And since we are finding in the map, so that is O of 1. So the time complexity will be reduced from n square m square to n into m square. Okay, let's write the code for this. So what I will do, I will run a loop for my row. So I should be less than n I plus plus. Now I will make pairs. So for int j is equal to 0, j should be less than m and j plus plus. While making pairs, suppose if I am at this place, so with 0 we can't make pairs, so skip that case. So if my matrix of this I and j is 0, so don't take that cases, so just skip, right? Continue. Now for making pairs, I will see my other one column. So for k should start from this j plus 1, K should be less than m and k plus plus. Again, if that cell is 0, so we don't have to consider that. Okay. Now we have got the two cells which are 1. So I will make a string temp is equal to string my jth column plus right underscore and then my kth column. Now I will check if my mp dot find for this temp is not equal to mp dot end. It means we have got this pair in previous row 2. So it means we have got the answer, so return true here. uh, okay, else we have to put that pairs in our map. So mp of this temp is equal to uh, 1, and let's declare this map. So unordered map, key is string here, and the value is bool mp. Okay, and in the last if no pairs we got like this, so we will just return 0. Okay, means false. Let's see it. Submit. Yes, I have done something wrong. Okay, unordered map for this string thing. uh, I loop for row, j for the column. Okay, and if I just 0, we will skip those cases. It will start from j. Yeah, here k will come. Yeah, it has been submitted correctly. Okay, so you can also see in this here, this loop is running for n times, this loop is running for m times, and this loop is also running for m times. So the time complexity is n into m square. And if you will talk about the space complexity, so the maximum space you can use, let's suppose all are 1 here, so the maximum pairs can be formed as m square. So the space complexity, time complexity was O of n into m square, and the space complexity is O of m square. Okay, so that's all from my side. If you have any doubt, you can comment uh, in the chat box. Have a good day. Bye.